Hello everyone, I'm Kirtana. I'm going to present about the first come first serve a scheduling algorithm, which is a part of a operating system subject and under the guidance of Sumana ma'am. Moving to the next slide, we will see in the introduction part what we will see is many programs run at the same time in a computer, but the CPU can run only the one program at a time. So the operating systems that decides which program should run first, and this process which is called as CPU scheduling. The CPU scheduling which helps in better performance and the faster responses. And our project's main goal is to design a FCFS scheduling simulator which accepts the dynamic arrival time and the burst time as input. We calculate the waiting time and turnaround time here. We test the program using these three different data sets. Finally, we'll check whether the FCFS is suitable for real system or not. Moving to the next slide. So, what is OS scheduling? In this, many programs run at the same time in the computer, but the CPU can run only one program at a time. So, the operating system decides which program should run first. This process is called as CPU scheduling. CPU scheduling, which helps in better performance and the faster responses. So, what is first come first serve scheduling? In this, first come first serve, which stands for first come first serve itself, which is nothing but the FCFS we say, and the process that comes first, that will be runs first. It works like a queue in a bank. It follows the FIFO rule, which means first in first out. It is a non-primitive algorithm, which means the process is not stopped in between. It's not interrupted in between. It is a simple, easy, but sometimes it gives the slow response for small processes. And the objective of this project, in the objectives, we will see the main goal of our project is to design the FCFS algorithm. We calculate the waiting time and the turnaround time here by comparing the results using the three data sets. We also check the whether is algorithm is good for the real systems or not. In this experimental setup here tools and setup, we have used programming language we have used is C, and the compiler we have used is the C++. The platform is Windows, and the inputs we have given to the particular program is the process ID, the arrival time, and the burst time. The output where we expect is the waiting time. It will give the turnaround time with a Gantt chart and the average values. In the first come first serve working steps, the step by step working process of the first come first serve. First, it asks the user to enter the number of processes, and then we enter the arrival time and the burst time of the particular process, and then it will sort the processes by arrival time. And the step 4, it executes the one by one. It's also in the step 5 will calculate the completion time, turnaround time, and the waiting time, and it's also draw the Gantt chart, and final it will calculate the average waiting time and the turnaround time. In the performance formulas, while doing the performance, there will be some important formulas. Like we use two formulas here: the turnaround time, which equals to that of the completion time minus arrival time, and the waiting time, which is the which equals to that of the turnaround time minus burst time. Using these formulas, we will calculate the all values. Here we will see the data set one output. In the data set, we have taken the three processes P1, P2, P3 with arrival time 0, 1, 2 respectively, and the burst time 4, 3, 2 respectively. And after calculating, the average waiting time will be 2.66 milliseconds. Average turnaround time will be 5.66 milliseconds. And the Gantt chart will be shown like P1 to P2 to P3, which is the order of the process. It will execute according to the arrival time in the first come first serve. which is the best performance as compared to that of the afterward these data set 2 and data set 3 outputs. Here we have taken the P1, P2, P3 as the processes with the arrival time 0, 2, 3 and the burst time 10, 1, 2. And then here in the third data set, we'll see the P1, P2, P3 as the pre-processes, arrival time as the 1, 2, 3, and the burst time will be 6, 8, 7, with the average time 7, 1, 11, and all. In this, we will see the slide shows the data set and the data set 3, which for data set 2, the average waiting time is 7 and the turnaround time is 11. Where for dataset 3, the average waiting time is 7.33 and the turnaround time is 13.66. Where the performance is very worst compared to that of the dataset 1, the dataset 3 has the worst performance. And this output, which is the when while we run the code in the div C plus application compiler, it will give the output as which will ask the user to enter the number of processes here. First, we will enter the number of, for example, we have entered the number of processes, that is 3, and it will ask the user to enter the arrival time of that particular. It will take the first process as the P1 itself, and P1 we have entered 0, and the burst time will be 4, and the arrival time for P2 is 1 and the burst time 3, and the arrival time for P3 is 2 and the burst time for P3 is 2, and it will give a chart of these three processes calculating the waiting time and the turnaround time, and it will show that with a table format. Moving to the next slide. Here the comparative analysis, what we will see here, we are comparing the all three data sets, data set 1, data set 2 and data set 3. Data set 1 which gives the best case, best, which means the best result itself. Data set 3 gives the worst result, which means the worst performance. And first come first serve, which also suffers from a problem which is called as convoy effect, where the small process has to wait for a larger processes. If they have come earlier and they're having a large burst time, the small processes even they have came later, but they have small burst time, they have to wait for a long time here. This is the convoy effect called, and we'll see the advantages and disadvantages of this. In this advantages part, we will see what the advantages of first come first serve are. It is very simple, very easy to implement, but there is no any starvation. No starvation, which means a process that has to wait for a long time because of the priority and all. And the disadvantages, we will see the convoy effect, as we discussed in previous slide, and the poor response time, because a small process has to wait for a long time and there will be no response, which is the poor response one and not suitable for that of the real systems. Into the next slide. In the conclusion part, we will see to conclude that first come first serve is the simplest and scheduling algorithm. It works well in the batch systems, as we know, and but its performance where becomes very poor when long jobs comes first. So it is not recommended all. And this project which helps to understand the what is CPU scheduling and the first come first serve working, how it's working, and we'll see the waiting and turnaround time to calculation also. Thank you.